So if at 5.1 as the main point, what do we have? 5.1 is that uh, particles of matter are in a constant move. And this motion that the particles are having is known as Brownian motion to honor the work that Robert Brown did in terms of heat that the object has. And now we said that at 5.1 that the faster the particles are moving, the higher the heat that the object has. And how do we reflect this? How do we see it? Is the temperature that the object is having. So the kinetic energy, because why kinetic? Because the particles are moving, and and the temperature are directly related with each other. So if the temperature of the object is high, then we can assume, we can draw the conclusion that the kinetic energy of the particles is high. And if the temperature of the object is low, then the kinetic energy of the object in comparison is lower. Now, when we are talking kinetic, we are saying kinetic because the particles are moving. And even on the first unit, we saw that all matter was composed by tiny particles. Uh, and then now we are saying those particles are moving, and this motion is known as the Brownian motion. So here we have a representation of quote unquote colder particles are cold. So what they are doing is they are vibrating into their position. They are moving a bit in comparison to what they are doing when the object is hot. They are moving more, so the vibration is increased. So what do we say, and what do we draw from the conclusion of all those connections? That matter is composed by particles. Particles are in constant motion. Uh, this Since they are in motion, we call it kinetic energy. The kinetic energy of the particles is directly correlated with the temperature of the object, which is reflected to us as a thermal energy, because temperature and uh, thermal energy are related to each other. Then we can say that particles that are moving less are reflecting less thermal energy, and particles that are moving a lot, like in this case here, are hot, and they are uh, the temperature is higher, and then the kinetic energy is higher, which is reflected into a higher thermal energy. This is even when we see like the beaker. Let's take a beaker that it is with a certain amount of water, and then at a certain temperature. What do we notice? Let's say that temperature is the room temperature. What do we notice in terms of the molecules of water is that they are vibrating less. However, when we observe in a microscope or on something that a water molecule that is with a higher temperature, let's say 80, 90, or close to boiling point, then what we will see is that the particles are moving very fast. So again, from 5.1, what you should take is the fact that from 5.1, what you should take as a fact is that particles are always moving, always in motion. Motion that is known as the Brownian motion to honor the work that Robert Brown did. And then the sum of kinetic. Why kinetic? Because motion and kinetic are related to each other. The sum of kinetic energy energy of the particles is direct reflected to temperature of the object. And then on 5.2, what you should take from is that heat so is related to motion of particles of the matter, motion of the particles, and the higher, the faster, I will say, the faster particles move, the higher temperature and heat and thermal energy is of that particular object. Okay, therefore the kinetic energy as well is. So those are the main things that you should take from the 5.1 and 5.2.